Okay, today we're going to talk about chemical reactions. Okay, when we look at a chemical reaction, this is where we have two or more elements and they're going to chemically combine and they're going to form a brand new substance. Look at the picture that we have right here. This is the elephant toothpaste, and this is where two liquids, when you look at the beakers, two liquids, and they're poured in there. They're both clear, turn brown, and then form this foam on there. So they're forming a brand new substance. And the other key thing to remember with this brand new substance, when it's formed, it's very hard to put it back in its original form. Okay, now let's take a look at this chemical equation. Now, a lot of times when scientists are mixing two things together, in order to represent it, we represent it with symbols down here. It looks very similar to a mathematical equation, and maybe that's a good way to view that. But it is a representation of two things going to mix together to form a product. What we have over here, there are parts of this equation. The first things that are written to the left of the equation, and the best way to view that is that arrow sign right here. So all the things to the left over here, the 2H2 and then the O2, all of these are the reactants. They're going to be mixing together. And then we have the other part to the right of the arrow. The things we end up with are the products. Just like in math, if you add 2 plus 3, your product would be 5. Okay, and our product over here would be water. 2 molecules of water to be exact. All right, now the other thing that we have up here, we have the reactants versus the products. Again, up here, the reactants are the substances that undergo the change. They're all the things on the left-hand side of the arrow, okay? And in this equation, it would be carbon and oxygen combined together. Okay, our products are over here. These are brand new substances that are formed. Okay, they're all the things that are to the right of the arrow. And in this equation up here in red, carbon dioxide, CO2, is the actual product listed above. Okay, now in here, what I would like for you to do is to take just a few minutes, and I want you to underline the reactants, or actually do this. Let me get my pen. I'll do the first one up here as an example. I'm going to circle the reactants, and these are on your graphic organizers. Those are the reactants, and then what I'm going to do, I'm going to change the color pen, and my products, I'm going to put a box around. Okay, so when you notice up here, this is the arrow. My reactants are to the left, my products are to the right. So on the next ones, I want you to complete this one, raise your hand, and I will come to you and check to see, do you have this skill, the reactants versus the products. If you would, you can pause this at this time. Okay, I'm going to move on. Just to recap again, endothermic versus exothermic. Think of the root word endo here. Endo, inside. Endo meaning inside. So endothermic, the reaction absorbs, or like a sponge, gathers in all of the energy, and it's very cold. Note that one, it's very cold or cooler. Our exothermic, think of exiting. Okay, think of exiting. Our exothermic, energy is released. It's released, and it is much warmer. So exothermic is hot, endothermic is cold. Okay, this is a recap. All right, so how do we know a reaction has occurred? One of the things that we see is gas forming. And this is not boiling water where you're seeing the water actually moving and churning. This is where if I were to mix an Alka-Seltzer tablet and put it in water and it fizzes, then that would be a sign of gas production. Or when you put vinegar in baking soda, you see the fizzing, the item there. The next one is that formation of a precipitate, and we will practice that one tomorrow and see it. It is where you mix two things together and it forms this solid that's in the liquid, and it is so heavy it will fall out. So like in this test tube, something was mixed together, and down here at the bottom is a solid that's falling out of this solution. Okay? Another one, energy is released. It's going to get very hot. We're going to see a lot of light color, and we're going to see a color change. And this just doesn't mean to identify the color red, the color orange, the color blue. This means that when you mix things together, do you get a brand new color, as in this beaker down here. They mix this liquid in there, it turns yellow, and then to blue. That is a color change. Okay. One last thing we're going to look at today is counting our atoms. We know an atom is the single unit, is the smallest thing that cannot be broken down, same component as an element, but your atoms are the counting units. So remember what we have over here on counting atoms. Number one, we do have a subscript. Subscript tells me how many. But there's also this big number that could be in front of it. And in mathematics, it's called a coefficient, the same here. And the big number coefficient, you would multiply it times the subscript. So let's practice this particular one right here. And in fact, let me go back to this one just to recap, though, before we practice. So you have a big, large number in front, the coefficient, and you're going to multiply it times each of the elements. If you have a subscript, that tells you that I have numerous ones, and you're going to multiply it. Okay? So let's practice this first one, 2CO2. All right, so let me get my pen, and I'm going to make it, we'll make it red. Okay. Now, right here, and I'm going to do it individually. I'm going to do it by the elements themselves, and then I'm also going to do this by the total elements that I have here, total atoms. All right, since there's no subscript behind C, it's understood 1. So that 1 times 2 gives me 2 carbons, okay? Now, oxygen, there's a subscript behind it that's a 2. So to find out how many, oops, and I wrote a hydrogen there, forgive me, that should be an O for oxygen, okay? So that O right there for oxygen, I want to know how many. Right now I have 2 oxygens, but that coefficient in front, we're actually going to multiply times it, okay? So 2 times 2 is 4 oxygens. Now, if I want to know total atoms in this one, I would just add these two together. 2 plus 4 gives me 6. So there's a total of 6 atoms, but if I wanted to break it down individually, there are 2 carbons and 4 oxygens. Okay? I'm going to help you out with this one right here. Magnesium, right here. Magnesium. I'm going to put Mg. Okay, Mg. So with magnesium, what we have right here, since I don't see a subscript, it's understood 1. Okay? We also have a capital O for oxygen. Okay? And we also have an H. Okay? So when I'm adding these right here, that O means there's only 1. But this subscript goes to everything that's inside that parentheses. So since there's 1 oxygen, and we're going to actually multiply it times the 2. So 1 times 2 gives me 2 oxygens. Okay, they're 2 oxygens. Okay? 2 oxygens. Let me see if I can make that a 2. There you go. All right. And then the hydrogen, since there's only 1 right there, the 1 times 2 is 2 as well. Okay. So, to find your total atoms, now we're on here looking. I have 1 magnesium, 2 oxygens, 2 hydrogens. To find your total atoms, you just add these together. 1 plus 2 plus 2. And when you do that together, you get 5 atoms of magnesium hydroxide. All right? And I believe that is it for today. I want you to finish up these 2 examples so we can check them. And then what we're going to do is have you complete a worksheet so we can check your skills. All right, thank you very much.